Okay. Right, so hello, my name is Josh. I'm a 16-year-old software developer who was doing their GCSEs, which got cancelled. So now I have been spending the past few months focusing on Edublocks. Edublocks is a project that I started 4 years ago when I learned Python from scratch and some other languages along the way. And I found that the transition from blocks to Python wasn't as easy as it possibly could be. And I created a piece of software called Edublocks, which you might have heard of before. And today I'm going to give you a quick overview of the software, and hopefully you can find it useful, and it would be great if you could take something away from this session and hopefully use it in your own classroom. So I am all about code on Twitter, or Edublocks on Twitter, and you can find my website edublocks.org if you would like to find out more, but I'll put all of that up at the end again anyway, if you miss it. So let's talk about the path from blocks to text. So a lot of teachers and code clubs and other coding workshops use two main block tools. You might use other ones, but the two main ones are Microsoft MakeCode for the microbit, which is a drag and drop editor for using the BBC microbit, which is a hardware board, and that's quite a good editor. It's quite popular. And Scratch, I'm sure everyone knows what Scratch is. Scratch is a visual environment which uses the same drag and drop block environment. And the good things about Scratch and MakeCode is that you have this visual environment, and you don't really need to know any programming skills to be able to use them, because all the blocks are in English, and it's quite easy to understand, like move 10 steps, and you can't really get any errors with these two programs. You can drag and drop the blocks into the workspace, and a lot of the time things will work. And once we have done Scratch and MakeCode, it's time to move on. I found when I started Scratch that I wanted to be a software developer for a while, since I was about 8 or 9, where I learned how to program in Scratch. And I was like, oh, well, I won't need to know anything other than Scratch, because Scratch is the best. And Scratch is really good, but you quickly realize that you can't get a job in software development building stuff in Scratch, unfortunately. And then a lot of people, so I attend lots of Raspberry Jams and events like that, and a lot of people say, well, you've done Scratch and you're quite good at it, why not move on to Python? So I had a look at Python, and I instantly didn't want to try it out. And there was a few reasons. It removed the visual environment that I was familiar with. So all of that drag and drop environment and the stage where you can make games, make stories and other stuff like that, it had been taken away, and I wasn't very happy about that. The drag and drop environment, it was really easy to do, to build programs. It was quick to prototype stuff and get stuff working. And there wasn't really any room for errors either. Errors aren't a very common thing in Scratch, especially Scratch 3. I know Scratch 2, you could sometimes get errors. But if you make a mistake in the program, the cat will just do something that you didn't want it to do, but the program will still work in a way. And Python didn't provide that. If you made a spelling mistake, then you got an error that wasn't very helpful. If you put a capital letter where a capital letter shouldn't be, then it wasn't very helpful and just gave you an error that you didn't quite understand. And that was kind of difficult. And when I did Python in school, I also found the same thing of other kids in my class found the same problems, and they didn't find Python to be a friendly environment. So there's a few main problems that I'm just going to summarize here. So the colorful blocks, the cat, and the visual environment have gone. And that can be quite off-putting, because the fun of Scratch and the fun of MakeCode is that you have that visual environment that you can actually see something. And printing hello world on a screen, for some kids isn't really that exciting for their first program, and it can quickly put them off and not want to do coding or computer science anymore, which is a shame. A big problem is that typing skills aren't necessarily the same across every student in a classroom. You've got some people who are really good at typing and some people who aren't very good at typing. And one of the main problems is we live in this world of iPads and phones where it's all touch screens. And a lot of schools are moving away from the normal desktop computers to iPads. And I've run workshops before, and people have asked what a keyboard and mouse is because they're so used to this iPad touchscreen environment that they just don't have the typing skills to take on a text-based programming language like Python. And that can be quite an issue because if you don't get things right in Python, then it will just complain with an error that you might not understand. Some teachers might not be confident in text-based programming. Teachers aren't software developers and aren't expected to be software developers. And learning a text-based programming language, especially for primary school teachers who have lots of different subjects to teach, they're not just specialized in one subject. They've got 6 or 7 subjects to teach in a week, and we can't expect teachers to learn text-based programming. So that can be quite an off-putting thing to have to learn that. And I've mentioned it a few times that Python can be frustrating with all the errors. If you make a very simple mistake, it can throw an error that you don't necessarily understand because you haven't learned the Python syntax, and that can cause kids to lose interest very quickly, and they just don't want to learn Python, and that can be quite difficult for teachers to manage. So what I tried to do is take the 3 kind of things I liked about, well, no, the 2 things that I liked about Scratch and MakeCode, and then kind of mix in the text-based programming element of it. So I combined the colorful blocks and the ease of use of the drag and drop, and then I combined the text. So originally my plan was to have a similar thing to Scratch where you got English words on the blocks, but then I thought, why not put the Python code on the blocks, so that as you're dragging and dropping the blocks, you're actually learning that code as well. And then the visual elements. Scratch has the stage and MakeCode has the emulator, and you can see something visual with the code, and that can be quite a nice element to Scratch and MakeCode. So I tried to take the more visual elements of Python, because there are some good visual libraries in Python, and combine that into this program. So 4 years ago, I started work on Edublocks, and it's still not quite finished. It's always getting stuff added based on feedback from teachers and students, but it's in a good place now where it's ready for people to use. Now, you may have heard of Edublocks before a few years ago and put it off because it only worked on a Raspberry Pi, but Edublocks doesn't just work on a Raspberry Pi now, and I'm going to show you a few of the new developments. So here's a quick overview of a few of the things that we're going to talk about today, the different elements of Edublocks and how it can help you and your students make the transition from block-based programming to text-based programming in an easy and simple way. So on the left, you have the Edublocks editor. And what Edublocks is it's a drag and drop block-based tool for learning Python. So I'll bring up a bigger image in a minute, but you should be able to see that each block represents the text, and you've also got a Python text view as well. So you can drag and drop the blocks from the menus, very much like in Scratch and MakeCode. In fact, the blocks are the exact same style as Scratch and MakeCode. so you're not having to learn a different block style. It works very much the same. And it's a really easy way to learn the Python syntax. So I mentioned before that you've got the Python syntax, which if you don't have a tab after a while true, then the code will error. If you don't put a capital letter, or you put a capital letter for print, for example, it will throw an error. All these sort of things. And Edublocks kind of removes that. You can still get an error, but it's much more difficult to get an error because the blocks are all set out. All the Python commands are set out in these block menus, which you can drag and drop and build your programs that way. But you can still view the Python code on the blocks. It's built with teachers and students in mind, so Edublocks along the way has always had input and feedback from teachers who use it, and also students as well. So, with me being a student, I've, gone through lessons where we've been learning Python, and from those lessons, I've been able to pick up what people are struggling with, and I've implemented that into the program, which has been really helpful as well. Edublocks also aims to provide a number of helpful tools and resources to assist the move from Scratch to Python. So with Edublocks, you don't just get the editor included, you also get lots of different resources, which I'll go through as well. So there are lots of different things to help you get started, and that's kind of the main aim of Edublocks, is to provide all of the resources, all of the tools to help teachers and students learn Python. So let's have a look at the different features. So the first one, which is probably the most important tool to help the aid from Scratch to Python, is the blocks. So the blocks are the main element of Edublocks, hence the name, and each block represents one line of Python. So here's a kind of an example of what a Python program would look like in Edublocks and what a text-based program would look like in Python. And you can see that you've got all of the import blocks, you have the loop blocks, and you also have indents as well. So these kind of gaps in the blocks to make the block shape actually represents an indent as well. And you can see that there's not a lot of room for error here because you've got the quotation marks, you've got the brackets, you've got the commands, and it's really simple to build up these programs. But at the same time, you're not kind of removing the fact that, one day you'll have to move on to Python because the Python is right there in front of you, no matter what you do, because the blocks are Python code. So you're learning Python as you're using it. Which is really helpful. And as you drag and drop in these blocks, you're kind of like, well, I need to have this import to be able to use time, and to have a forever loop. In Scratch, you've got this block style for a forever loop. So, that must mean that that block is a loop and code needs to go inside of it. So you're still borrowing those principles from Scratch, but you're putting them in a Python-based environment. And it generates Python code there, and all of the code is run in the browser. So you may use Trinket, and Edublocks actually runs programs inside of Trinket. So it all runs in the browser, whether you're using a Windows device, a Mac device, or an iPad. So you don't need to install anything, because I know that can be quite a pain for teachers to have to get stuff installed, and it's not necessarily the easiest thing for some schools. You've also got a blocks and Python split view. So I know the blocks have the Python code on them, but it is sometimes helpful to see the text as well. So with a click of a button, you can have the Python view on the right and the blocks on the left. And if you drag and drop the blocks, you can see the Python code being generated. So I mentioned before in the introduction that one of the main elements of Scratch is this visual environment, and Edublocks kind of brings that over using two main libraries. So the first one is Python Turtle, which you probably have used before, and Python Turtle will allow you to make these fun graphics. And there's also processing, but processing Python library. And you can see here that that brings a lot of the mouse movement interactions in with it. So the one of the classic Scratch examples is get the cat to follow the mouse cursor, and you can see that this example on the screen, hopefully the video is playing, the dot follows the mouse cursor. So you can kind of bring those visual libraries into Python learning as well. So I borrowed the same kind of principles from Scratch here. This is from a Scratch presentation, but the same rules kind of apply here. So you've got low floors, wide walls, and high ceilings. So if anyone wants to get started with Python, they can do the very basic hello world example. But then if people want to extend to the visual elements of processing, you can get quite advanced with processing. There's lots of creative options. And you can also use a number of different platforms like the Microbit and the Raspberry Pi and standard Python 3 as well. So you're not kind of limited there. But also if you've got more advanced students who, you know, have done a bit of Python at home and want to do something a little bit more advanced, then the option is there for them as well. So you're not kind of limiting anyone in what they can do with Edublocks, similar to Scratch and MakeCode as well. Another handy feature of Edublocks is that once you've done your projects, you can easily share them via Classroom and Teams. So if a teacher wants to set some starter code, they can create an account on Edublocks, they can make their program, and if you're logged in to a teacher account on Google Classroom, then you can press the Share to Classroom button next to the saved file, and that will allow you to create an assignment within Edublocks to then be able to set some starter code. And then students logged into their Classroom accounts can press the same button, and then they'll be able to select a class and then select an assignment and then press the Go button, and then it will automatically send you, the teacher, that file, and you can open that up in Edublocks just with one button press. So that's really handy for teachers that are doing remote lessons at the minute, and they want a very simple way to integrate with Classroom and Microsoft Teams as well. And Edublocks allows you to log in with Google, Apple, and Microsoft accounts, which are kind of the main accounts that schools have. But also, if you don't have these, you can log in with an email as well. But you won't have the Classroom and Teams functionalities, or you can use it without a login. You don't have to log in, but you get all of these handy features if you do. So Edublocks doesn't just work with Python 3 on the web. You can also use the BUC microbit. So all the microbit commands, like scrolling something on the display, shaking the microbit to do something, reading the temperature, all those sort of things, you can do within Edublocks. It's very similar to MakeCode in that you have extensions. So I know the Bitbot and the Move Mini from Fortronics and Kitronic are quite popular robots in schools. And Edublocks both has extensions for these robots, of which you can use. The Raspberry Pi as well, so you've got more advanced things like accessing the GPIO pins, using Minecraft, and CircuitPython, which I know is not as popular in UK schools, but CircuitPython is one of the main platforms in US schools. So there's that option as well, but you may have Circuit Playground Expresses in school as well. Everything with Edublocks is free, and I made a pledge at the start to keep it that way. So both the editor and the resources is free for everyone to use, and you don't need to pay for storing files, you don't need to pay to use the editor or to download any of the resources, which is kind of one of the main aspects of the program, so that there's no barrier to entry if you can't afford the software in your schools. So that's quite a handy feature as well. So it's 100% free to use for everyone. So you can use it on any platform. It's all web-based, so you can use it on iPads, you can use it on laptops, you can use it on computers. It's very simple and easy to use on anything. As long as you're not blocking Trinket, you shouldn't really have an issue. So anyone can use it on any platform, which is especially handy in home learning situations where high-end devices or things like that aren't available to some students. Anyone can use it as long as they have an internet connection and a web browser. So that's kind of a feature overview. Now let's talk about some resources for teachers. So one of the main resources for teachers is the 6-lesson Python scheme of work. So this is a new edition that was added about a month ago. And what this is I find that if you're learning Python, so if you started off from scratch, it's very easy to just get caught up in dragging and dropping the blocks and not really knowing what it does. So what all the blocks do. So you've got the core programming concepts like iteration, selection, and all of those. And Edublocks scheme of work, what this kind of does is it reinforces those key programming concepts at the start and then builds around those in 6 lessons through Python Turtle and also core Python concepts like print and while true and all of those sort of things. So each lesson is based around a different programming concept like iteration and then data types, variables, functions, and sequence and all of those sort of things. And there's slides and lesson plans for all of the lessons. So there's a full PowerPoint presentation of which is a fully guided lesson and a lesson plan to go alongside that. And I'll show those in more detail after the presentation. And they're really handy if you just want a very quick start for a scheme of work, and that covers 6 lessons plus an assessment at the end, which I think is about 10 or 11 questions, and the assessment covers everything learned in the previous 6 lessons and asks questions based on what you've learned. And then there's a mark scheme giving you marks for the different questions. So that's good as well. And it's free to download, so you don't need to pay for this scheme of work either. And it's based around the AQA spec. So the person who wrote this scheme of work, I gave him the AQA specification for the new specification, and it's based around the programming concepts in that specification. So it is a Key Stage 3 scheme of work, but it's good to kind of reinforce the stuff that you'll be learning at GCSE as well if your schools offer that. It's always good to have that prior knowledge for students that are going into GCSE. And the reason we went with AQA is that's just what I did at school. And I think it's quite popular anyway. So the 1, 2, 3 coding cards are also another good resource for teachers. And these are very basic flashcards that kind of resemble the Scratch flashcards. So there's 10 basic cards, and each card starts from basic and then gets a little bit more advanced. And each card has a program in Scratch, and then a program in Edublocks, and then a program in Python. So you're kind of working your way through the Scratch to Python transition in these cards. And these can be quite a good starter activity or a backup activity for students who aren't necessarily that confident in going straight into Edublocks or Python yet. And these can be quite a good activity to link between the 3 programs. I mentioned earlier that it can be quite easy to not know what the different blocks in Scratch do, and this can be quite a good way to reinforce that through the 1, 2, 3 coding cards. And these are really easy and simple to use. There's also a number of home learning resources on the Edublocks website. I'm going to mention 2 here. And the first one is a home learning pack, which was created by a teacher for his class, and it has a detailed getting started guide, so you don't need to have done Edublocks before in lesson. The pack of resources actually has a getting started guide, which shows you the different features and how to navigate the interface and stuff. And it also has 4 Python Turtle worksheets. So you might notice that Turtle's coming up a lot because I find it quite a good resource for getting started in Python, but adding that visual element back in. And the worksheets have starter code, and then under each bit of code, the student will be asked, what they see and what they've learned and all of that sort of stuff. And it has extension activities as well for students that want to go a bit further. So these are really good self-guided worksheets if you want to get started using Edublocks now or in September if schools are still doing remote learning. These are really good, but you can also use these in classrooms as well. You don't have to just use them for remote learning. It's just based around a home learning environment. Another good starter activity for home learning is video lessons. There's about 20 of these video lessons which have been created by teachers, and I've made a playlist on YouTube with all of these videos in them. And the videos go through the different starter very basic activities, and then some of the videos are a bit more advanced, and these are really good to be able to have virtual lessons at home. And these are all self-guided because you can see which block is from where, and it's a really good activity for a fully self-guided learning activity at home. And they introduce the core Python concepts and the core programming concepts as well. So I'm going to show you a quick demo, hopefully, of Edublocks, so you kind of get an idea of what to expect. So if I go here, so this is the main Edublocks website, so edublocks.org, and this is what you get presented with. And if you press start creating, then you get this window here. So I'll be doing a Python 3 example here. So I just click on the Python 3 mode, and then something that I quite like to enable that I'm considering enabling as default in the next version is split view that I mentioned before. So split view, as you drag and drop the block into the workspace, I'll just make it a bit bigger because it might be a bit small, you can actually see the Python code get generated on the right hand side in the Python view. So you can see that all of the menus are set out in different categories. So you've got logics, which has the if statements and stuff like that. Lists for doing stuff with lists, and then statements is stuff like input, print hello world, things like that. You also got definitions for doing stuff like functions, turtle, which has the turtle commands, random for doing stuff like picking stuff out of a random list, and variables as well for creating a variable name like that. So if I drag a name variable here and then do an input, what is your name? I'll keep that as it is, and then get a while true loop there, and then we'll do print, and then drag a variable block for name, and then so it doesn't go too fast, we'll do time.sleep. So you can see here that the blocks code matches up with the Python code on the right, and what you can do here is press run, and that will open up a trinket window. And then if I type my name in here, which is Josh, you can see that it will print my name. I'm not sure how clear that is, but you can see it prints my name every second, and it will do that until I press the stop button there. And I'll show you the Google Classroom integration. So if I log in with my Google account here, select the right one, And then if I press files, you can see I've got all of my files here. So if I open my Turtle Spiral program, then add something in here, 0, then run that. You can see that that will do the turtle spiral that I showed in a few of the slides. And then what I can do here is press save because I've edited it, go into files, find the file, press share, and then I have this shared Google Classroom button here. And what that will do is it will generate a URL which you as a teacher can see in Google Classroom. So this is a student's perspective here. So if I press Year 8 Computer Science, which is just a demo class, and then first program assignment, press go, you can see that what that will then do, if the internet works, is it will take the file here, so you can see a view of the code there, and it will give you a link which you as the teacher can just click on when the student has turned in the work and your assignment is ready to turn in, and then you can just submit that. But as I mentioned before, you as a teacher can also use that to set starter code for students to access and then change as you'd like. So that is a demo of the editor. So if I just show you the curriculum website, which is curriculum.edublocks.org, I'll put all of these links up at the end. And if I go into the first lesson, you can see that you have a Google Slides document here. And this is the first lesson is more of a theory lesson rather than actually using the program. So it goes through basic things like, you know, what is coding, kind of reinforcing the basics, and then going through what everything is. And then one of the activities here is writing your own language. So you've got the block character at the start. How can you get to the finish line by creating your own programming language and avoiding all of the obstacles? And then we talk about moving from Scratch to Python, and then using the different features within Edublocks and stuff like that. And then making the link between all of the 3 languages. And then alongside that, get the right tab, you have a lesson plan, which has things like learning objectives, key vocabulary, preparation of the different pedagogy, things that you need in a lesson plan. And then you have the outline of how long you have to spend on each slide and guidance for teachers on what everything in the slideshow is. And you've got 6 of these folders with a lesson plan and a slideshow. You also have a assessment, which I'll bring up. So this assessment here has things like what does this do, and what is a variable, and things like that. And then you've also got the mark scheme, which goes alongside that with the different answers. So that is a demo of the 2 main resources. So what's in Edublocks for the future? There'll be a new user interface, which basically just brings the split view down to the main screen to make that a little bit easier to access. There will be machine learning integration with machine learning for kids, which is now supported by Scratch and Python. In the next release, Edublocks will have integration with machine learning for kids via the main website there, and also a Scratch style start block. One of the main problems which teachers have brought to my attention over lockdown is that students are putting blocks which aren't in the main stack and they're getting errors. So what this will do is it will have a Scratch style start block which you attach your code to, and then it will disable all the blocks that aren't attached to that. If you'd like to find out more information, you can go to the Hello World article that I wrote in issue 13, and that's quite a good reference point for everything that I've talked about here. So it's question time now, I think. So thank you for listening. If you have any questions, please ask them in the chat or email me as well, or message me on Twitter, and you can get the different websites and editors and curriculum information on the screen now. So I think it's time for questions.
Thank you very much, Josh. That was absolutely fantastic session. I've got a few questions that have come through while you've been presenting. I'll share those with you now, and then I'll keep an eye on the question window for any new ones as they come. So we've got a question here which says, can you change the Python code and the change be reflected on the blocks?
So that is something I'm working on for the next release. The reason I haven't got around to that yet is I wanted to do it a while ago, but I had my exams to focus on. But now I've had some time to get some of these features in. That's one of the features that I'm going to be working on. Brilliant,
thank you, Josh. What year groups would the 6-lesson scheme of work be suitable for?
So what I recommend is that if you do Scratch in year 7 as kind of like a starter, so in year 7 do like Scratch and then cover some of the core programming concepts, because not all primary schools do programming the same, so it's good to always start with Scratch. So kind of end of year 7, start of year 8, but it's really up to you as to where it fits into your school's curriculum. But year 8 is kind of like the good year for that.
Excellent. And speaking as a primary teacher, I think some of your stuff could be, you know, the way that you've designed all this stuff is excellent and makes it even accessible, I would say, for some of our more able primary coders, which is great.
Yeah, definitely.
Python's one of those things that a lot of primary teachers would sort of actively avoid, as it's not necessarily in the primary curriculum, but this is a really good way in. Do you have an official YouTube channel, Josh?
I don't, but what I am going to be working on in the next month or so is converting the official curriculum into video lessons, which will be going on a YouTube channel. And what I'll be doing is I'll be putting them all on the curriculum website and the main Edublocks website as well. So that's kind of the main area to look out for those.
Yeah, that would be fantastic. There's a lot of love in the questions bit at the moment, Josh. People are incredibly impressed by your webinar today.
Thank you.
Someone's even said that they expect you'll definitely get an A star or whatever the equivalent is now. I can't remember, it's numbers now, isn't it? In computer science.
With the
based on this
the exams have been marked. Yeah.
Yeah. Someone's asking, where did you learn to code, or sort of how did you sort of get to this point? What started it all off?
So I go into a bit more detail in my Hello World article, but to summarize it up, I went to Preston Raspberry Jam, which is where I'm from, and that was run by Alan O'Donoghue, which I'm sure basically everyone knows from his articles and stuff that he does. So I learned to code in Scratch there, and then from there I've met different people who are software developers, and I managed to pick up Python and TypeScript and HTML from them, and I kind of dedicated all my spare time to learning how to code, and that's kind of how I got started, and it's just something I really enjoy doing, and I've stuck with it.
Brilliant. We've got a few questions coming through about primary. Let's see, what do you recommend as a primary school we can do to enable children to develop a love for computer science?
So I think that make sure that it's not boring, like I've said a few times. Like it can be quite easy to start with you know, getting the cat to say hello, or you know, I know in my school there were a few lessons on, you know, just printing hello world and getting variables to work because students just didn't have the confidence to learn Python. And I think starting with basic stuff and then building your way up to the more advanced stuff is a really good option, because it can be quite tempting to go for this, you know, really good looking advanced program that might look exciting, but if students can't complete it because they just don't have the knowledge of, you know, Python or Scratch, they don't have the basics, then they can lose interest very quickly by things not working. So it's really important to start with the basics first, as much as it might be tempting to go into the more advanced stuff. Starting with the basics is a really good way to make it exciting. And, you know, like I've said, bringing those visual elements of Python, visual elements of Scratch are really important because they're the stuff that gets kids engaged.